Greetings, everybody. All right, we're moving on from the integumentary system now. We're going to go to the skeletal system. Got a nice little run in here, showing the outline of the skeletal system. It's really bone. We're talking all about bone today. So let's get right to it, right? All right, what is the function of the skeletal system? You can pause if you want to think about it, or you can just keep going. All right, so we're going to talk about 5 different functions. Some of the obvious ones: it provides support. All right, it keeps you upright. All right, it's kind of the central building block of your body. Right. It helps with protection. Like the rib cage will help keep the lungs and the heart from being hurt on impact and whatnot. So you get some protection, movement. Right, the bones offer the framework for you to allow you to move in conjunction with muscles. You've got mineral storage. Bones help contain reserves of minerals like calcium that are important outside of bones. And if you're talking about homeostasis, like we talked about a little bit about calcitonin and calcium levels, if your blood calcium levels get too low, your body will take it from your bone and help potentially weaken your bone. And then blood cell formation is another one. You're going to have all the blood cells are going to be produced in the bone. And then there's the store and release fat over here, which you can kind of view as this. Right? These are both going to be types of marrow that we're going to talk about. But again, the function support, right, helps keep the body upright. Protection helps cushion or keep some of the more valuable organs from harm. The central rib cage. Movement allows you to move. Mineral storage and blood cell formation. All right, bone structure. You're going to have a couple different bone types. There's the compact bone, which is in the outside, and you can see the compact bone is kind of lines out. So you have this layer of cartilage outside of that, and then you have a compact bone, which is a dense bone, pretty strong, but it's also perforated by these pores, eversion canals that allow the blood vessels and the neurons to go through it. Then inside the compact bone, you have a layer of what's called spongy bone, which implies that it is soft, but in fact it actually allows the bone to be a lot sturdier. So the spongy bone is called this because it has the perforation of, you got all these pores in it, and these pores, if you look over here, another picture of it, allow a framework much like steel crossbeams or crossbeams in building structure, allowing for a stronger support network of the bone than it otherwise would be. If you had the compact bone, or it was just filled with compact bone, it would be kind of weird. But the spongy bone itself does allow for it to be stronger because of those kind of cross beams that are forming it. It's very strong. And then inside of that, right, contained within that, the inner part here is the bone marrow. We'll talk about that. 2 different types of red and yellow. But you do have the bone marrow. And for those of you who have fractured a growth plate, this is the growth plate that goes across here, and this is where you're kind of dividing the new cells forming a growth plate in there. Anyway, that's kind of a nice little view. So again, you have the compact bone, which is a nice, thick, dense bone that has these pores that allow blood vessels and neurons through it. And then inside that, you have the spongy bone, which is this network of crisscrossing fibers, not fibers, but bone, that allows it to have a stronger support network that is also perforated with blood vessels and neurons. And then inside that, you have your bone marrow. And then on the end, you have a nice layer of cartilage that surrounds it. Well, that's your basic bone structure. And you will feel pain if you break it because of those neurons. And you'll get bruising if you break your bone too because of these blood vessels in there. But I digress. All right, how do bones form? Nope, sorry. Wrong slide. Bone marrow. Inside there's two types, yellow and red. Bone marrow. Yellow is fat storage, kind of the fatty marrow. And it's usually when people talk about bone marrow transplants, bone marrow donations, and whatnot, it is going to be with the red. All right, the red bone marrow is what's producing your blood cells, both red and white. So you're going to have some immune cells be formed there, and then your regular hemoglobin red blood cells that are going to be transporting oxygen through your blood. If you want a visual more on that, like if you have the example comes to mind is like chicken or chicken bone. If you have like a chicken leg, you have the bone left over, you crack it open, you'll probably see some red bone marrow in there. That dark stuff inside is the red marrow. Some people like to eat it. I am not one of those. All right, so now I got ahead of myself earlier. Let's go to bone formation. All right, when you're born, you are, I believe that's something like 90, 95% cartilage, very, very little bone. I don't remember the exact number off the top of my head, but it's cartilage. You see over here. Cartilage is just a very flexible but tough connective tissue. You can't really break it. You can bend it in all sorts of directions. You want to, example, your ear is cartilage, like the tip of your nose cartilage. Your ears are pretty flexible. You can't really break your ear, can you? But over time, as you grow, right, as infants grow into toddlers into bigger kids and adolescents, your bones form, and you start with these osteoblasts that secrete minerals that replace cartilage and bone, and ultimately you form these osteocytes, which are bone cells. Osteo, you may have figured, refers to bone, and the site here refers to cell. So you're really just a bone cell. But over time, as you grow and your bones grow and they lengthen and whatnot, you end up replacing this cartilage with actual bone cells, and that develops into that compact bone, that spongy bone. You do have a layer of cartilage on the outside, and this process is called ossification. It's the process of bone formation. But your mature bone over here, you can see it's much different from that cartilage. It's filled with blood cells or blood vessels. I want to go back for a second here, and so that growth. But once you have kind of matured, even like so, adolescence, when majority of that cartilage has been turned to bone and you're still growing, that growth is going to originate here in that growth plate, right? And these cells are going to develop and make your bone larger. And bone growth. So you have this kind of a more magnified picture of bone growth. You have the cartilage, you have the replacement here, and then you have bone. Just kind of a neat picture. All right, the final thing to talk about. There are many different topics that I won't be able to get to today, but there's a lot of vocabulary in this unit, particularly with this next part, with joints. So you have all sorts of bones in your body, 206 bones in your body, and most bones will end up meeting another bone. When those two bones or more meet, it's called a joint. Right? And these joints can be immovable, right, which allows no movement, like the skull. Right, the head of the skull is a bunch of bone plates that are joined together, and these don't move. And you can see the fissure marks here. This is where the plates are they meet, and those are the immovable joints. And the movable joints allow movement, as the name implies. Another term here, ligament, which you'll hear about. Ligaments are connective tissues that join two bones together. And sports injuries you hear, like ACL, MCL, those are ligaments. ACL is a ligament in the knee, helping joints and bones together. So yeah, if you tear a ligament, you're hurting where those bones are meeting. There's probably some joint issues there as well. All right, so the type of joints, this has got more than your book has. I'm just going to do the ones that your book has. It's a nice view, kind of gives you a look at what the motion does. You have a hinge joint, and that gives you the back and forth motion, like your knee or your elbow. You have your ball and socket joint. That's a little mistake there. It shouldn't be an arrow. And that ball and socket joint is kind of rotational, almost 360. I mean, it's the shoulder or the hip. It gives you that ball and socket rotation. The saddle joint is going to allow for, I think I've also heard this one called a gliding joint, where these two bones slide across each other. Your thumb is an example of a saddle joint. And the pivot joint is where you have just kind of a fixed rotation around another bone. And the neck is an example of a pivot joint. You can kind of move side to side, but you're limited otherwise in that degree. And so you get the hinge, ball and socket, saddle, pivot. You should know examples of each, and the types of joints, ligaments, a lot of terms and examples. And then that's all for today. Thanks for listening. And I hope the rest of your day goes as swell as this presentation has gone. See ya.